Today's lesson is 2.4, Solving Systems of Inequalities. Today we're going to talk about how to solve linear systems of inequalities. These are the four inequalities that we are going to see. And let's go ahead and start talking about our boundary lines and our shading. So when I have the less than or greater than symbols, my boundary line, the line that I'm going to draw for my graph of my function, is going to be what is called dashed or dotted. It has to have space left in the line. When my inequalities are less than or equal to or greater than or equal to, then my line is going to become solid, showing that everything is there. Okay, so notice that the way it becomes solid is it has to have that or equal to bar. So that's the first thing you need to look for. Then we're going to go ahead and shade. When I see the less thans, these are the less thans, okay, either just less than or less than or greater or equal to, then I am going to shade below my line. Your intuition is going to be your best friend in this case. Most of the time when you pick what's below, you know it's below. But I'm going to show you another trick as well in case you're not quite sure if you should shade that portion of the graph or not, okay? When your symbols are greater than, the greater thans, either greater than or equal to, we're going to go ahead and we're going to shade above our line. And once again, your intuition is going to be your best friend. So what are solutions to my systems of linear equations? What are my solutions? Well, they're going to be all the coordinates in both, in the shaded region. Sorry about that. By both inequalities. That doesn't, wait a minute. Hold on. Let's grab this. I think it would make more sense if we said the region shaded by. There we go. By both my inequalities. It has to be the overlap. The parts where your two colors are intersecting each other. So if you notice right here, the solid line, which is an or equal to line, is being shaded below. So it's less than or equal to. The dashed line is also being shaded below, so it is simply less than. Notice that right in this boundary right here, the two colors of the shading are overlapping. This is where my solutions lie. Now, if a point was exactly right here on the solid line, it is also considered part of the solution. However, this point here, since it is on the dashed line and it is not equal to, it is not considered part of the solution. So yes, part of the solution, no, not part of the solution. Just the points on the lines, just the points on the lines. All right, let's go ahead and talk about how do we do this. So we're going to go ahead and practice a few examples. Let's go ahead and graph the system of inequalities. So once again, we're going to use our same technique. We're going to call this one equation 1, and we're going to call that one equation 2. We're going to go ahead and take equation 1, and we're going to make sure that we can graph. That means it has to be in the y equals mx plus b form. It's just that instead of equals this time, we have to have a less than or a greater than sign. So just to remind you, we are looking for this form so that we can graph. But in this case, we're really having that, or we're having that, or it's going to be all together, just less than, or just greater than. It's not really going to be equals this time. So if I take a look at my line over here, y is not alone. There's that 3 being multiplied by it. So what I like to do is I like to circle the inequality because remember, an inequality can flip on you. It only flips if you divide by a negative number. And I'm hoping that I'm going to show you that today. I'm pretty sure I am. We're going to go ahead and we're going to divide by a positive 3. Remember, everybody gets divided by the positive 3, which is not going to flip our sign. It's not going to flip our sign. So y is going to say greater than or equal to 1/3 x plus 2. 6 divided by 3 is 2. Now I can go ahead and I can say y equals mx plus b. This is simply to help me decide what my slope is. It is, of course, 1/3, right? There's my slope, 1/3. And to help me decide what my b is, my y-intercept, it is 2. That's the only purpose for that. Remember, we always begin our graphing at the beginning. And then our slope shows us how to move. In this case, 1 up and 3 to the right. So 1 up, and 3 to the right. 1 up and 3 to the right. Remember, you can always come back to your beginning point. You can always come back to your beginning point. Let me put those points. You can always come back to your beginning points and reverse and go down and to the left 3. So down 1 and to the left 3, down 1 and to the left 3. There we go. Go back and take a look at the circled inequality just to decide should it be solid or dashed. It does have the bar, so that means we're going to go ahead and make it solid. We do have to decide where we are going to shade next. So let's go ahead and take a look. It is greater than because it's pointing to the right. That's always greater than. And so that means I'm going to shade above. So I'm going to let me grab my highlighter actually to shade. You don't have to shade perfectly. It doesn't have to be shaded right, everything be shaded. It just needs to be shaded, okay? Color is probably a little bit best, but your pencil will work because you'll see where the two parts of your pencil shade together. I wouldn't shade super heavy with your pencil though, because you do want to see that overlap. All right, let's go ahead and take a look at equation number 2. Let me see where I have some space. I'm going to squeeze it in right here. I hope it's okay. Oh yeah, it should be pretty good. Here we go. So I'm going to circle that inequality. Remember, it can flip. It can flip. So I just want to make sure that it's not going to be flipping on me. I want to get the variable y by itself. So all I have to do is move the 2x. It's a positive 2x, so I simply subtract it to the other side. Remember, it's not going to actually subtract negative 2x minus 5. I did not divide at all, so my inequality is going to stay exactly the same. All right, I can write the y equals mx plus b underneath, and that's simply to help me decide what is m and what is b. For this graph, of course, my m is going to be -2. Remember, whenever I have a whole number for a fraction, 1 is my denominator. And my beginning point, my b, is of course -5. So I'm going to come down here to 1, 2, 3, 4, 5. Now, -2 over 1 would mean down 2 and 1 to the right. I really can't go down 2. Look, 1, and I don't have any more graph. So I'm going to go in the opposite direction. 1 up, 2 up, sorry, 2 up and 1 to the left. So 2 up, 1 to the left, 2 up, 1 to the left. I want to just continue this pattern until I run out of space, and there's my last one. So let's put those points in. Remember, we're not looking for where they're overlapping this time. We're looking for where we're not looking for the intersection, we're looking for the shading overlap. Okay, go back and look at your sign. Go back and look at your sign. Does it have a bar? No, so it has to be a dotted line, a dashed line. I like to kind of just put one little line through each one of the points. I need to see space so that I don't count it wrong that you've graphed incorrectly. This symbol is greater than, so I'm going to shade above. Now, my intuition tells me this is above. I want to know if I'm right. So let's take 0 as 0 and 0 as a test point. Is 2, what's 2 times 0? Well, anything times 0 is 0. So I have 0 plus 0. Is 0 plus 0 greater than -5? Well, 0 plus 0 would be 0. Yes, that is greater than -5. So I need to shade the 0. I hope that made sense. So notice as I start to shade my purple, notice as I start to shade my purple, right in this area here, it kind of becomes blue because that greeny color and this greeny color and this purple color, or this light blue and this purple, are becoming a nice like royal blue. This section right here would be my solution. These would be my solutions, okay? Now, it does ask me which one of the following are solutions. I'm just going to go ahead and check each one of these points. I'm going to check them with my laser. If they are an answer, I'm going to go ahead and circle them with my pen. So let's take a look at -5, 1. 1, 2, 3, 4, 5, 1. Is this a solution? No, because it's only in the light blue. That is not a solution. All right, how about -2, +4? -2, 1, 2, 3, 4. There's -2, +4. Yes, because that is in the royal blue section. So this would be an answer. There we go. How about 3, 3? 3, 1, 2, 3. Is that an answer? Yes, yes, it is because it is on the solid line. It is on the solid line. So let me put those in there. 1, 2, oh, 1, 2, 3, 4. There we go. And then 1, 2, 3, 1, 2, 3. There we go. There's those two so that you can see why they are solutions. 2, -1. 2, -1. This one is not a solution because it's only in the purple. And -4, 3. 1, 2, 3, 4. 2, 3. Now, it's on the boundary line, but because it's on the dotted boundary line, it is not a solution. So these are not solutions, just those two are. You have to check them all because there can be more than one. All right, let's take a look at another one. Graph the system of inequalities. So once again, we're going to go ahead and call this one equation 1, and we're going to call that one equation 2. Let's go ahead and get started with equation 1. We're going to have to go ahead and solve for y equals. There we go. We're going to have to get that variable y alone. Remember, we could see that flip in our inequality. All right, there is an addition, but I need to be careful because it's really the addition of a negative. So I'm going to go ahead and have to add the 2x to the other side to make it cancel out. I cannot add the -3 and the +2 because of the variable x, but I do want to write them as 2x minus 3. That's because of my y equals mx plus b purpose. Now I'm going to go ahead and I'm going to divide by 3. And since I am not dividing, ooh, I need to bring this down a little bit more. Since I am not dividing by a negative, my inequality is going to stay exactly the same. Take a look at your numbers. Um, Get your numbers right here. We like to circle them so it kind of looks like 2 eyes and a nose. We're not going to change it because we see nice positive eyes. So we're not going to go ahead and flip our sign. There we go. I can go ahead and I can say for certain what my slope is and what my y-intercepts are because of this. So my slope is going to be 2 over 3. I'm going to go 2 up and 3 to the right. And then, of course, my beginning point is going to be -1. And I got that simply from using the form. All right, remember you always begin at the beginning, which happens to start with B, and then you go ahead and you do your movement. 2 up, 3 to the right. 2 up, 3 to the right. And you just simply do this until you cannot anymore. Then you go back to the beginning, and you go in the opposite direction. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. This just gives you a more precise graph, especially when you are shading. All right, go back and look at your inequality. It does not have a bar underneath it, so that means it must be dashed. Once again, you need to make sure that you see a visible space in between. So I just kind of like to put one little dash through each of my points, leaving some space. All right, let's go back and look at it. It is less than, so that means I'm going to shade below. My intuition tells me that this is below. Remember, I can always check 0 to see if I'm correct. I simply plug it in here and here. 2 times 0 and 3 times 0 would, of course, be 0. 0 plus 0 is 0. So is 0 less than -3? No, no, it is not. So I would not shade 0, 0. 0 is bigger than -3. So I'm going to go ahead and I'm going to shade where my intuition had told me to. Okay. But did you see how easy it was to check? Once again, I just checked 0, 0. That's because I should almost always be able to come back and say 0, because it's a number times 0, plus 0, a number times 0. 0 plus 0 is 0. Is 0 less than -3? No, 0 is bigger than -3. So I don't shade. All right, let's go ahead and take a look at equation number 2. Now, equation number 2 is not in y equals mx plus b form. It is in that special form of x equals. when I have a graph that's in this form, I get a vertical line. Get a vertical line straight up and down at this number on the x-axis. So I go to x equals 3, 1, 2, 3, and I'm just going to basically have a point everywhere up 3 and down 3 on the y-axis. All my x's are 3. I'm going to go back and I'm going to look at my inequality. It does not have a bar underneath, so I have a dashed line. Now be careful in this situation. I tend to like to maybe skip because once again, you need to see that um, it has been left open. Now, you might be thinking, what would be above and what would be below? What would be above and what would be below? Well, let's check 0. Let's check 0. Okay, there's 0. 0 is less than 3. Yeah, that's true. So these would be considered below. These would be considered above. And if you think about it, this is positive infinity and this is negative infinity. So that makes sense where less than is and where greater than is. Okay, let's grab our purple highlighter and let's highlight. Once again, my solution is all this place where I'm starting to see that darker royal blue. There it is, nice and dark. This spot up here with just the purple, and of course I didn't shade everything. I can come back and do so. That is just the purple solution, line solution, and the light blue is just, of course, for the light blue line solution. All right, let's take a look at which of our following are solutions. -2 and -1. -2 and -1. No, it's only in the purple. Cross it off. 1 and -2. 1 and -2. Yes, that is a solution. 1 and -2. Yes, that is a solution. 3 and +1. 1, 2, 3 and +1. Ooh, that's a tricky one. Remember, if the lines are dashed, it is not a solution. And take a look. The lines are both dashed, not a solution. Let's take a look at the next one. 2, -5. 1, 2, 1, 2, 3, 4, 5. Yes, it's in the dark blue spot. That is a solution. And our last one, +3, +5, 1, 2, 3, 1, 2, 3, 4, 5. No, it's only in the purple, and no, it's on the dotted line. So that is a big no as well. All right, let's go ahead and check another one. The more practice we get, the better we'll be at going ahead and graphing these by hand. Now, I probably will be showing you in class how to use the calculator to graph these because yes, our calculator will graph these. But for the video's purpose, I have to continue practicing by hand simply because I don't have the calculator on my device. All right, so I'm going to draw a circle around that inequality because remember it can flip. I'm wanting to get that variable y by itself. So first I'm going to take the x and I'm going to move it to the other side. It is negative, so I'm going to go ahead and add it to the other side. Remember, they're not going to combine together. We're simply going to go ahead and write x first and then, nope, it's -8 because it's a -8. Remember, whenever there's a number in front of the variable, we are hiding multiplication. So to get rid of it, we're simply going to divide. This is where I'm going to look to see if I should flip my inequality. Notice that the number that I'm dividing by is positive, so my inequality will stay exactly the same. 1/4 x minus 2. My y equals mx plus b is going to help me to find m and b. My m is, of course, 1/4, 1 up, 4 to the right, and my b is, of course, -2. I always begin at the beginning on the y-axis. I move 1 up and 1, 2, 3, 4 to the right. 1 up, 1, 2, I can't anymore. So let's go back to the beginning. Let's go back to the beginning and let's go in the opposite directions. 1 down, 1, 2, 3, 4 to the left. And we can't go anymore. Let's go back and decide if our graph should be dashed or solid. It doesn't have the or equal to sign, so let's go ahead and make it solid. And you can kind of continue the pattern if you choose. Let's go ahead and decide where to graph. Greater than. Greater than means shade above. And to me, that's this place up here. Remember, we can always check 0. Is 0 plus 0, which is 0, greater than -8? Yes, 0 is bigger than -8. So let's go ahead and shade where we thought we would. I'm telling you, your intuition is almost always going to be correct. It's just those crazy ones like x equals or y equals that mess us up. All right, let's take a look at equation number 2. I'm not going to have to do any dividing here. There's no number in front of the y. I'm simply going to go ahead and move that x. It is positive, so I'm going to subtract it to the other side. It's not going to change my inequality. I'm just going to write it as -x plus 3. Remember, this is what's helping me decide what my slope is and what my y-intercept is. My slope is going to be, of course, -1. Remember, whenever it's a whole number, I simply put it over 1 to make it a fraction, and my y-intercept is going to be 3. So I'm going to start at +3 right there on the y-axis, and I'm going to go down 1. Let me change my color. Down 1 and 1 to the right. Down 1 and 1 to the right, down and 1 to the right. Ah, I love these combos because it's so simple to do. Remember, I can always go back to the beginning and switch up 1 and 1 to the left. So up 1 and 1 to the left, up 1 and 1 to the left, up 1 and 1 to the left. My inequality does have a bar underneath it, so it is going to be a solid line. There we go. Let me get the right icon. Perfect. And I just have to decide, should I shade above or should I shade below? It is less than, which is below. So I'm going to say this part right here, which of course, look, does contain 0. So let's ask ourselves, 0 plus 0 is 0 less than or equal to 3? Well, yes, 0 is less than 3. So I was correct. We're going to shade right in here. Now, this part here is not the solution, but this part here is. There's my solution. Let's make it nice and dark blue. Perfect. There we go. Let's take a look at our ordered pairs. -3, +1. Yes, that is a solution. -1, +4. -1, 1, 2, 3, 4. Ooh. Yes, because the purple line is solid. That is a solution. That is a solution. Tricky. How about 3, 0? 1, 2, 3, right there. Ooh, another tricky one since it's on the purple solid line. Yes, that is a solution. Yes, that is a solution. How about 0, -2? It's on the line once again, but this time it's on the blue dotted line, not a solution. And the last one is 2, 1, 2, 3, negative 4. In the purple only, not a solution. All right, for sure, I'm going to show you how to do this one in the calculator at school. I hope you are here for that. If you're not, please just ask me to show you. Unfortunately, I don't have my graphing calculator here on this device. And then we'll practice one more time with our calculator in school for example 4, so it will go a lot faster in class, but I do want to show you this one quickly by hand. So equation number 1, I'm going to go ahead and I'm going to have to manipulate it. I'm going to have to move that 5x to the other side, and I'm going to have to divide by that positive 2 so that my y value can be by itself. Okay, so I'm going to go ahead and subtract the 5x since it was a positive 5x. No, I cannot subtract 5 from 8 because of the x. I'm going to go ahead and put my minus 5x first and then put my plus positive 8 next. Remember, I'm going to go ahead and get rid of that multiplication by dividing. Remember, when I divide, I need to look at the number that I'm dividing by. If it does happen to be a negative, that is going to switch my inequality. It's not negative, so this one is not going to switch. And 8 divided by 2 is, of course, 4. This is just helping me so that I can graph. This is just helping me so that I can graph. And let's go ahead and graph. So my slope would be negative 5 over 2, which would be 5 down and 2 to the right. Or remember, you could switch them, 5 up and 2 to the left. And my y-intercept is going to be 4. So let's start at 4. 1, 2, 3, 4. And we're going to go 5 down, 1, 2, 3, 4, 5, and 2 to the right. 1, 2, 3, 4, 5, and 2 to the right. There we go. That's all the points I can get. I can tell already that by going up, I only have 3. I'd be guessing, and so I don't want to go ahead and do that. I'm going to go back and look. There's no bar underneath, so this is a dashed line. This is a dashed line. You just want to make sure that you can tell that it is dashed. Now let's go ahead and look at the shading. It is greater than. My intuition says this one, which does not contain 0. Let's just double check. 0 plus 0, which is 0. Is 0 greater than 8? No. So then I was right with what I was thinking. My intuition was correct. Okay, there we go. Let's go ahead and do equation number 2. Take a look at equation number 2. It is already in y equals mx plus b form. Okay, it is already in y equals mx plus b form, where my b is 4 and my m does not exist. If my m does not exist, it is 0 because 0 times x is 0. And so that's why the x is not appearing. So I'm going to go to the 4, 1, 2, 3, 4, and every 4 along that line right here is going to be, that's my 0 movement. I'm not moving up. I'm only moving left or right. I'm not rising at all. Okay. Go ahead and look at the inequality right here. Go ahead and look at the inequality right here. It does have the line underneath, so that is a solid line. There we go. And now I'm going to go ahead and decide, should I shade above, should I shade below? This one is very easy to see. This one's probably the most easy to see, but once again, above, below, right? I feel like Grover, near, far. But once again, notice that above has the positive infinity and below contains the negative infinity. So you can always use your infinities to help you out as well. Let's go ahead and look at our inequality. It's less than, so we're going to shade below. It's less than, so we're going to shade below. Remember where our two colors are meeting? That is our solution. Oops, that got a little crazy. There we go. All right, last thing, let's go ahead and look at our ordered pairs. -1, -3. Nope, it's only in the purple. -3, +4. 1, 2, 3, 1, 2, 3, 4. Although it is on the line, it's only in the purple. Nope. It's got to be in that dark blue, that royal blue. 2, 2, 1, 2, 1, 2. Yep, there we go. There's a point. 2, 2. Yep. How about 4, -6? 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, it's on the line, but it's on the dashed line for the blue. Nope. 4, 0. 1, 2, 3, 4. Yes, that is clearly in the blue shaded region. There we go. You might be thinking everyone would have two answers. No, remember example 3 today had 3 answers. It just depends.